Hello everyone, I'm Maria from IPACK Solutions, Cadence's channel partner in the MENA region. Welcome to the third video in our Celsius Studio series, where we're going to introduce the different types of thermal simulations that can be performed using the various applications available in Celsius Studio. In the previous video, we demonstrated how to perform a static electromagnetic co-simulation in Celsius 3D Workbench. In this video, we'll show you how to perform a transient electro-thermal co-simulation in Celsius 3D Workbench. So here I have the environment open in front of me. I'm also going to be using the same design that I used in the previous video. So briefly, this design includes a BGA with two wire-bonded die, and it is placed on a PCB. I previously defined in the previous video the PCB, the solder balls, as well as the molding for my BGA and the two dies. In the previous video, we made multiple setup. We defined which components will be generating power, the heat transfer coefficient, check how the temperature is being passed from the BGA to the PCB. We also defined the VRM and the sinks. So now we'll be doing the same for the transient analysis. Now, instead of having to redo the setup, I can just copy the parts from the static analysis. I can just select them over here and move them from the static to the transient analysis. And I can do any changes to them directly over here. So I'm gonna select D1 and select modify. I'm gonna change it because previously we specified the power as fixed. However, now I want the power to be dependent on the time. So I want to define for it a function. I'm gonna define for it a pulse function. I want it to be one cycle and to be repeated. I'm gonna specify a few of the parameters over here quickly. And I can select apply, and over here I can see the function before I save it. I want also to do the same for my second die. So now my dies won't be generating a fixed power, however, a power that changes with time. I want to define a function. Let's add multiple points for this function. Let's specify the power here to be 0.1 at 0.1 seconds. I want the power to be 1 at 0.5. I want it to be 3, and same, I want 1.2, I want it to be 0. So here I can see my function, and then I can select OK and save all of the changes. Now I can also copy the heat transfer condition. Let's copy them over here. Same for the VRM. Let's copy it over here, and same for my sinks. Let's select them. Oops, and copy them over here. Now for my first sink, which is the one for D1, I want to modify it so that it receives power dependent on the time. So let's select sink current. Let's add a few values. Let's change the function. I wanted to say that after 0.5 seconds, I want the current to be 6 amps. However, at from 0 to 0.2, it is 0.5. So I'm gonna select OK. And now that I have made all of the setup necessary, I'm gonna go to my options window, and I need to make sure that I have selected a transient analysis, an ET co-simulation, and I have set up the transient simulation. I specified the duration of my simulation, of course. Now that this is done, I can start solving. However, it takes quite some time. I have previously done the simulation, so I can open the results quickly over here. Alright, now I have my results. Let's only select a few objects that I want to see. I also want to see, for example, the temperature. I want to see the surface. And I can, for example, check at 1 second what is happening, at maybe 2.2 seconds what is happening, at 5 seconds how the temperature it is. You can see first D1 has temperature of 185.8 degrees Celsius, and maybe at 10 seconds the temperature of D2 has risen more than D1, and it's now 222 degrees Celsius. Alright, we can also check the IR drop if I wanted to, so I can see at multiple timestamp what is happening as well with the voltage. It's changing as well as it a bit. You can see with the increase of temperature in T2, there's an increase in a drop in the voltage. And with that, I'm gonna conclude this video where we have introduced how you can do transient analysis, transient electrothermal co-simulation inside of Celsius 3D Workbench. In the next video, and it is also the final video in our series, we're going to introduce how you can do electric cooling in Celsius EC. So we'll see you in the next video.